Hello everyone. I hope you had a great week. Um, if you are in Miami-Dade County, you enjoy your free day today. But we need to keep going with our tutoring, so let's continue with what we were doing last week. Also, I want to say that we need to hurry. Also, I need to hurry explaining because I already finished Unit 1 with algebra. Look at how much we have left with geometry. So let's try to hurry a little bit more. But I know geometry takes time, so I'll try my best. Now, what are the coordinates? Like question 3. What are the coordinates of the centroid of triangle CAT with vertices C negative 3.1, A negative 2.4, and T 5, negative 2. First, I'm going to do my scale. So I have my picture here, and I'm just going to draw 95. So here I should be good. So -1, -2, -3. Oops. -3. 1, 2, 3, 4. Please tell me I'm good with this. Yes. 1, 2, 3, 3, 4, 5. The Y is the X and this is -1, -2. Now, right now, you might be asking what is this centroid? Um, the better thing to do if you don't know is just go here to Google, put centroid of a triangle, and I think their images they are actually. I want to show the images. I found one today, but they showed the centroid on the other 2 points. But okay, basically, as you see here, is the one that goes to 1 point to the middle of the other line. So from B to the middle of AC. That's basically the central. No, I don't think I'm going to send the table through Discord today. The table I was looking for. But just to let you know. So basically, let's first put the point. So -3, 1 is C, -2, 4. This is A. Oh, cat. I love kitties. I didn't realize that before. 5, -2. So this is A. This is B. And this is the mm, okay. It's acceptable. This is the triangle. Okay. Now we know that the center will be something like this, but we want to calculate it. So let's just calculate the midpoint of um the other side. So the midpoint of CA. We can do the formula, but since I already explained the formula in other videos, what I would like to do now is just counting. And this is 1, 2, 3, and this is 1. So this is 3, and this is 1. And the like 3 divided by 2 is 1.5. So I count 1, 5. So this is the y coordinates. 1 divided by 2 is 0.5. So it will be from here. And I do here, and my midpoint is going to be right here. And the coordinates will be um, negative, negative 2.5, since I see here. And the midpoint here will be right here at positive 2.5, comma 2.5. Now I'll delete this since they're in the middle, but just to let you know, for this one in city of 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3. So this is 8, and this is 3. The middle point of 8, what I mean is 8 divided by 2 is going to be 4. So 1, 2, 3, 4. It'll be over here. So I go up and I see that this is going to be exactly 1, the x coordinate. Now the middle point of 3 is 1.5. So I go 1.5, like 1.5, and I see that the this will be 1.5, like negative 0.5 will be the coordinate, but this will be the middle point between this part. So if I continue this, I'll see that the middle point will be here at point 1 comma negative 0.5. But if you don't understand, let me know. The formula for midpoint, you can always use it. I explained it before, but just to let you know, it's m, like midpoint, equal x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. I just don't, like, I explained it before, and I don't think if you're consistently watching this, you're going to need it right now. So this is 1, 2, 3, 4, 5, 6, 7, and I also want to hurry. So this is 7, and this is 1, 2, 3, 4, 5, 6. This is 6. 7 divided by 2, 7 point, like 3.5. So 1, 2, 3.5. They are here in the middle. So here in 1.5. And 6 divided by 2 is 3. So 1, 2, 3 in 1. I go here and it will be here at 1.5 comma 1. Now we have the middle point, so let's do the central. Wait, centroid. I confused with biology for 1 second, sorry. So from here to the midpoint, right here, from here to the midpoint, oops, to the midpoint. Oh, that's actually, this is just a right line, like here, from here to the midpoint. Yeah, we can see that it's almost in 0, 0.1. Is that in our options? Yes. Right here, option C. Since the is right here, the intersection of the three lines. Yep. And that's basically how they solve this. And one exercise took us 9 minutes. Just ah. Now, quadrilateral star has vertices. Those. Which statements are true? Now we don't have the quadrilateral, and we want to know which statements are true. So let's draw it first. Mm, okay. And we need 10. 1, 2, 3, 6. We need 10 points. So basically, from 3 to 13. So basically, I'm going to say do this. No, I'm not going to have enough space. I'm just going to do 2 points for squares. That's the best we can do. Now this is 2, 2, 4, 6, 8, 9, 10, 12, 14, and this is 2, 4, 6, and 8. We don't need more than this. Now we have point S 3.5. We go to 3, and I go to 5, so S it will be over here. T 7.8, so 7 will be over here, 8 is here, so this is T. 13.5, 13 will be over here, 5 over here, so 13, oh, 13.5 is A, so 8. Now 13.0, we right here. This is R, so S star. Withdraw, and we get that this is our quadrilateral, like our figure. Now, is TA equal to SR? So TA, SR, since the very first moment I'm visualizing this, just by by visualizing it, I see that this is a lot shorter than this. So TA is not equal to SR. You can always use the distance formula if you're not sure. But this is just to scale. That's the reason we're using the point. So it's actually easy to visualize. This is a lot shorter than this. Oh, this is not true now. Is ST equal to AR? I actually want to calculate this one. I'm going to use the distance formula, which is the square root of x2 minus x1 square plus y2 minus y1 square, and this will be st will be 3 or wait 7 minus 3, so 7 minus 3 square plus 8 minus 5, 8 minus 5 square. This will be 4, like 7 minus 3, 4. 4 times 4 is 16 plus 8 minus 5 is 3. 3 times 3 is 9, so this will be 16 plus 9, 25. The square root of 25 is 5. So we know that ST is 5. Now, RA, since it is like a straight line, I'm just going to count the units, and I know that this is 1, 2, 3, 4, and 5. So we also have 5 in this side, and I count. Don't forget that I put two numbers like this. Is 1, this is 3. So I put 2 in one square. That's the reason I'm counting 2 for the square. So we know that the distance for AR is also 5. So this is true. Now, is TA parallel to SR? SR? What? SR? They appear to be so, but to make sure we need to know the slope. The slope is m, like little m, that stands for slope, equal y2 minus y1 over x2 minus x1. Now that we know that, we are going to select y2 as a, so m equal a will be 5 minus 8. 5, oh, this is from TA. TA. 5 minus 8 over 13 minus 7. 13 minus 7. We have that it is negative 3 over 6, which is the same as negative 1 over 2. So 5 minus 8 is negative 3, and 13 minus 7 is 6, and we divide 3 divided by 3 1, and 6 divided by 3, and just divided by 3. It's 2. That's the reason I got 1 over 2. Now, if we want to know the slope for this smaller, oops, oops, wait. I'm now put it here. And I want to know the slope for, okay, I got 1, I 1 over 2. For SR, we do the same. So it will be 0 minus 7, 0 minus 7 over 13 minus 3. 13 minus 3. Okay. Okay, never mind. I was just trying to see something. And we have that 0 minus 7 is negative 7. Yeah. And this is going to be 10. So we have that the slope is negative 7 over 10, which is not equal to the 8, so therefore they are not. And that's it. Yep. So this is false. Now SD is parallel to AR. Now SD parallel to AR. In the very first moment, we know this is a straight line. This is a diagonal, so it's impossible that they are parallel. Since like we can see that in the graph. And now quadrilateral STAR is a trapezoid. Now the condition to be a trapezoid is that at least one of the opposite sides are parallel. And so as we can see here, they are not parallel. Wait, let me make sure because this is weird. Mm, Yeah, no, I did it right. Wait, no. This is 5. The coordinate for S is 5. It's not 7. S is 3, comma 5. I'm sorry, I got confused. I I can say that many of you should have realized that. So I'm sorry if I yeah, that was really bad for me. Now I go here -5 over 10, and if I divide both 10 by 5, I'm going to get 1 here. I'm going to get 2 here, so this will be 1, -1 over 2. And now it does make sense. I was like, wow, that was so weird. I was not expecting that. That's the reason. Always check your result is what you get is not what you were expecting. So yes, TA is parallel to SR. Now we can go to analyze. The properties to be a trapezoid is that one of the opposite sides, at least one, is parallel. So yes, a star is a trapezoid. I'm sorry, I'm really sorry for all the confusion. But basically it. Like if you search it up, you're going to see that. And now is a star an isosceles trapezoid? Now is when like this part become important. Since the non-parallel sides are equal, then we can say that yes, quadrilateral star is an isosceles trapezoid, and that's because the non-parallel opposite sides are equal. And that's basically it for this exercise. Let's keep going. Wow, they're really, really long. I'm just trying to see, like, since we have already done many of these. I don't know if they are too. Okay, I just keep going. Now, quadrilateral task has vertices. Let's draw it. Oops. Oops. Okay, perfect. Now, negative one, like 1 comma -1, that will be here. This is T. Now, 1 comma 2, going to be here. This is A. 3 comma 2, this is 1, 2, 3, so 3 comma 2 is here. And 3 comma -1 is here. If you're doing this in a test, you need to label everything since we are looking to save time. I'm just going to keep going here, here. Okay, this is acceptable. Now, which of the following statements are true? Set all that apply. AS is parallel to TK. AS, yes, they are parallel. As you can see, they are a straight line here, and there is a straight line here. So they are both parallel. Oh, they're both equal. Well, I answered this. They are equal because they are a straight line, and there is 1, 2 here, 1, 2 here. So yes, they are equal and they're parallel as well. Now, TS is equal AK. Yes. Yes. This is AK and this is TS. Now, I'm going to leave this for last and I'll to continue just to let you know something. TA perpendicular AS. TA perpendicular AS. Yes. Why? Because they are like this is a straight line up and this is, let me draw in a better way. So, and this is a straight line in the horizontal direction. So this is up and this is right, and there is no like diagonal anything else, so they are um perpendicular to each other. And we all can also say these also are perpendicular, these are perpendicular, and these are perpendicular since the TA and KS they're both in the vertical direction, and AS and TK they are both in the horizontal direction. So TA is perpendicular to AS, and TS now is one these chains TS and AK. TA, I can say that TA is not perpendicular to AK just by visualizing the graph, but if you want an explanation, it's just that they don't have an inverse and opposite slope. If we calculate the slope, we're going to add that the slope of this one. I'm going to do use rise over room, so it will be one. Oh, I'm going to use another color. It will be 1, 2, 3, and it will be 1, 2. So the rise will be -3 since it's going down, and the run will be 2. And if I do this one, it will be um like this one. The T and TS will be 1, 2, and it will be 1, 2, 3. So the rise will be 3 positive and 2. So as you can see, they are opposite, but they are not reciprocal, so they are not perpendicular. Now, quadrilateral task is a rectangle. Yes. Why? Because the four sides are perpendicular. Um, AS is equal to TK and TA is equal to SK. Because like we can easily visualize it in the graph. And now that we know that task is a rectangle, I want to go to part B. In all rectangles, the diagonals are going to be equal. It also works for squares, since squares are also rectangles. But the properties for rectangles are that the opposite sides are equal and parallel, and like the four angles are right angles. So we fulfill all the requirements here. So it is a rectangle, and since it is a rectangle, the perpendiculars, which are these two lines, are also equal. But if you don't know this property, if you don't want to learn it, just use the distance formula, calculate it by yourself, and you'll get the answer. So I can say that this is true. And now, is quadrilateral task a rhombus? The properties for a rhombus is that all sides are equal. That it has four sides and the four sides are equal. And since you can see this side is a lot greater than this side, we say that no, task is not a rhombus. Now in theory 3 is almost the same. I'm not going to do theory 3, just do it by yourself. If you want to you can take a screenshot of this and do it by yourself. You can ask me for the Discord if you want, but let's just keep going since it's almost the same. Now which type of triangles has vertices? Those. Then we need to graph it. And let's see. I'm going to say here and here. And the point will be R2, 1. So this is R. 2, 5. 1, 2, 3, 4, 5. This is S. And T is 4, 1. 1, 2, 3, 4. This is T. Oh, this was 4, so this is T. It was 2, so 2, 3, 4. So this is T. We have this as our triangle with R at 2, 1, S 2, 5, and T 4, 1. Help. Okay, you understand what it is. Now, rectangle triangle, right? Acute isosceles equilateral. Um, since we have, let's first see what we have here. We have one horizontal line and one vertical line. So this is horizontal, this is vertical. And since they are opposite, we know that this is a right angle. Now for the side, we see that this is a lot shorter than this. Since these both are different and this is the hypotenuse, we also know that this is gonna be different. So these three sides are like different, so the triangle is going to be right since it has a right angle, and it's going to be scalene since all the sides are different. Now we go to our answer, we say, okay, right, acute, no, isosceles, no, equilateral, no. Now, acute, no, because we have the right angle. Isosceles, we need two sides equal. Neither of these sides are equal. Equilateral, we need the three sides equal, which is obviously not happening here. Now, theory 5. Let's do the same. A negative 3 comma 0, so this is A. B negative 1 comma 2, this is B. And C 0 comma negative 1, this is C. Okay, now we want to know the same. So let's just draw our triangle. Okay, now simple side, we can say that we don't like there is no opposite. It's like wait. Let's first calculate the slope because maybe you cannot say it first side. So the slope for AB will be 1, 2, 1, 2. So 2 rise over 2 room, 2 room in the positive direction. So it's just going to be 1. Since 2 over 2, 2 over 2 equal 1. Now here, this will be 1, wait, 1, 2, 1, 2, 3. Never mind. Oops. This will be 1 and 1, 2, 3. So it will be rise. It will be 3 in the negative direction. So it will be negative 3 over 1, like over room, which is just negative 3. And here it will be 1 and 1, 2, 3. This will be 1. It will be 3. So the rise will be 1 in the negative direction. So it will be negative 1. The room will be 3. So it will be negative 1 over 3. Now we have the slopes, and as we can see, any of them are opposite reciprocal. BC and AC, They are reciprocal, but they are not opposite, so we don't have any right angle. Now, a simple side, we can like for difference between acute and obtuse is that the acute angle, triangle, I explained this some videos ago, but the acute triangle, the angles are all less than 90 degrees, so it will look something like this. While the obtuse triangle, it has one angle greater than 90 degrees, so it will look something like this. By sample size, I can say that this is an acute triangle. So this is less than 90, this is less than 90, this is less than 90. If we want to know which sides are equal, we see that this has 2 and 2, so no. We have that this has 1 and 3, and that it has 1 and 3. So since they have the same displacement using different direction, I can say that this is equal to this. They have a 3 and a 1 of the displacement, and it has a 3 and a 1 in the displacement. So I know that BC is equal to AC. So this is an isosceles triangle since it has two equal sides. While an equilateral has three equal sides and then the scalene has non-equal sides. So this is an isosceles acute triangle. And when I go to my answers, no, it's not right. No, it's not uses. Obtuse, yes, it is isosceles. And no, it is not equilateral. No. Quadrilateral man has vertices. What is it? Let's go. I'm going to need to make like two per square. So negative a. This is negative a. mm, Negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, and 10. Now, I didn't see this before, so I need to do it again. Sincerely, with geometry, the part that takes the most time is just realizing all the drawings. So this will be negative 2, negative 4, negative 6, and negative 8, 2, 4, 6, 8, 10, 2, 4, 6, negative 2, negative 4, negative 6. Now m is negative 7 comma negative 2, so it will be here 0 comma 4, so this is a. T 9 comma 2, so this is T. 2 comma negative 4. Okay, so this is H. Now when we draw this, we get this, this. Yeah. Now let's do the same as we did with the triangle to see the slope for M is going to be MH. 1, 2, and 3. Don't forget that we put wait. 1 and 2. So this is 2. We put 2 per square. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So rise over room will be negative 2 since it's going down over 9. Now this is empty. Empty equal. HT will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So it will be 6 over 7 is going up, rise over room. So HD. Now the A will be 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2. It's going down. So AT equal negative 2. Rise is negative because it's going down over room. So 9. Now MA will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And A will be rise over run 6 over 7. This is MA. Now as you can see, they have the same slope, the opposite side have the same slope, so they are parallel. And as you can see, the opposite sides have also the same numbers. So 2 and 9, 2 and 9. This is 6 and 7, this is 6 and 7. So they are parallel and they are equal, they are congruent. And now the fours, like the four sides are not equal. So this is not a square, so it's not a square. It's one of our options C. For a rhombus, for it to be a rhombus, the four sides also need to be equal. Yes. Wait, I got confused for 1 second. Yeah, but yeah, you see, the four sides need to be equal. So this is not a rhombus even. Now for it to be a rectangle, this angle will need to be perpendicular, and as you can see, the slope are not opposite and reciprocal, so this is not a right angle, I'm sorry. So this is not a rectangle. All we have left is a trapezoid, but it is. It has at least one side of opposite and equal, so the correct answer is a trapezoid. Now I'm going to do the last one. Um, which is 37. I'll continue next week. I hope we can cover more information. This is just too long. But let's continue. I put it here. Now I'll trade x equal y. X is not equal to 0. So I just say that x is y is 1. I want to work with easy numbers, so x is 1. Since x equal y, y is also 1. So it will be 1 comma 1. This will be 2 comma minus 1. This will be negative 2 comma negative 1, and just keep going. Now, oops. Okay, it worked. But let me. We want like I'm going to say -1, -2, -3, 1, 2, 3, 1, 2, 3, -1, -2, -3. Now L will be 1, comma 1, so this will be L. N will be 2, comma -1, so this will be M. N will be -2, comma -1, so this will be N. And P will be -1, comma 1. Oops, here this is L, this 1, comma 1. So -1, comma 1, and this is P. Now we draw our quadrilateral. If you don't know quadrilateral, just mean that it has 4 sides. To see the slope, you see that, like a simple side, we see that this is an horizontal line. This is an horizontal line. This is an horizontal line, so they are parallel. This is a vertical line, so vertical line intersecting an horizontal line. We have a right angle here, and we have a right angle here. Now, this is a diagonal, so this is just the other side now. It's not a square. To be a square, it will need to be like this. So it's not a square, we can say it. A rhombus needs to have the 4 sides equal, and you can see that this is 3 units, this is 2 units, this is 2 units, and this is 2, like we need to calculate it using the design formula. But it will be a square root of 5, basically. So no, it's not a rhombus. It's not a rectangle because for it to be a rectangle, this side will need to be parallel to this side. As you can see, they are not. And also the 4 angles will need to be right angles, so it's not a rectangle. It's not a rectangle. And we are left again with trapezoid. And since we have a pair of sides that are parallel to each other, which is BL and M. Yes, this is our trapezoid. Most specifically, this is a right trapezoid since these two angles are triangles. The other type of trapezoid is an isosceles trapezoid. I think we did one today. It will be something like this. Okay, like bad drawing. I'm bad at this. It's just that it has, okay, this side is parallel to this side since it's the property, like we need to, for it to be a trapezoid, and then this side needs to be equal to this side. That will be an isosceles trapezoid. Just for you to know, that's all for today. I'm sorry for being too fast. If you don't understand, just ask me, go to Discord, interrupt me and say, hey, wait, explain that again, or can you say it slower, or show me another way to do it. I will do it. Just go to Discord, go to the live session, ask me question through the question channel. Is everything in there? Just see it if you are right now in Discord. Okay, and you don't understand, unmute yourself. Let me know. Yeah, that's it for today. Thank you for watching, or either live or the recording. Thank you. Let's see you. I'll see you next week.